Hey guys, this is Nsum5 bringing you another Redstone video. Today I want to go over some of the basics of clocks, managing different pulses, being able to observe the pulse and measure it, and then reconciling those pulses so that they all fire at the same time. Alright, sounds like a lot, but it's not really that bad. Let's get started. This is a basic switch all in black. Just basic switch coming out of that. Now, this is a standard 5x5 clock. Now, let's say I didn't know what this clock was running at. I could tell that it was clocking, but I didn't know exactly what it was clocking at. How could I measure that? Alright, this is a meter. It's a trick that I saw Johan Lundgren use. He's a really great sorting builder, and he uses this to pull different pulses and times and just see where his machine is at as he goes from module to module. I've seen other Redstone users use it also, but he was the first person that I saw use it. So, to read the meter, all we got to do is get it just above our toolbar and then pause it for a second. Now, if you're playing solo, you can do this. If you're playing on a server, what you got to do is just take a screenshot and be able to access those screenshots and go back and forth between the screenshots in the game. But we can see right here that there are 5 on pulses and 5 off pulses, so it's a 5x5 clock. Now, let's say we want to delay that by 1. We put in 1 unit of delay, this little repeater right here, and we turn it on. Now, how can I compare those? Alright, I can see clearly right here that the one unit of delay has shown up in the meter. So that's pretty cool, and it's pretty good, useful tool. Now, I want to add some more delay, so I add 4 more than the previous unit. So that should show up when we read the meter. Alright, so here's the leading edge of the meter, is right here at the end, and then there's 1, 2, 3, 4 gap. That's exactly what we would expect. So 1, 2, 3, 4. Alright, let's go a little bit farther. We need to be able to change the pulse for this machine, whatever this happens to be. And we need it to do a 6-4 instead of a 5-5. So we do 1 unit of a basic pulse extender, and we can turn that on with that. And let's check that. So we've got 6 on, 4 off. We've achieved our goal of reaching a 4-6. Now we need a 7-3, so we added 1 more unit of pulse extension. Let's check it with the meter. And we've got 7 on, 3 off. Alright, so how do I shorten the pulse? That actually took me a ridiculous amount of time to figure out. I hadn't seen it in a tutorial, and it was counterintuitive to me, but the solution is so simple. If you want to shorten a pulse, you just reverse it. So here I've got a 7-3, and here I've got a 3-7. So now that we can do all of that, we want all of the machines to fire at the same time. Now, and granted, all of this is spread way out just to illustrate the basic points of how to get this done. There's multiple ways to do it. You can achieve delay much easier than just stringing together a bunch of repeaters. You can use comparators as your clocks. for the pulse extension. There's all sorts of ways to do it. I just wanted to do it the biggest way to spread it out and show you. This iron block panel is to resolve all of the pulses so that they fire at the same time. So what we want to do is we want to examine all the pulses and compare all of them and see which one is delayed the most. So I came through, checked everything, and this one is the farthest one behind. Cool. Now all I got to do is see which ones are the ones immediately in front of it and add one delay. Now I find which one's immediately in front of that and add 2 delay, and you just go through and you check the meter all the way. So like this one, when we said that it was 4 behind this one, in order to reconcile those two and make sure all these are firing at the same time, we add 4 more. Basically, when you're trying to resolve pulses so that they all fire at the same time, what you pull from one side of the equation has to go to the other side of the equation. So 4 delay here, 4 delay here. A net, when you count that one, 1, 2, 3, 4, 5 delay here. This one's coming straight out, so it's got 1, 2, 3, 4, 5. Anyway, guys, so I just wanted to show you how with having multiple pulses, multiple delays, how you could spread that out, get a visual representation of what's going on, and then be able to reconcile all those so that every one of those clocks is firing at the same time. And that one's off. But just to reconcile it so that making sure all these are firing at the same time. Once you can do this and reconcile them, you don't necessarily need this control wire going all the way down, accumulating delay and just being another wire. You can go from end to machine if you know how much delay you need to add along the line. So this is a really good thing to know because you can cut back on your overall redstone work. Alright guys, if y'all have any questions, any suggestions or anything, just let me know. Like, share, subscribe. I hope that this was able to help y'all out. I'm sure it probably opened up more questions than solutions, but it shows you some of the basics in just getting clocks and delays down and getting them all to work together. Alright, thanks guys.